Welcome back to another Algebra 2 video. This is another quadratic series video. In this one, we're going to talk about how to find roots or x-intercepts using something called the quadratic formula. Now, when we found roots before, what we did was we had to use functions that could be factored, right? And we would factor the function and then go from there to find the roots and draw the picture. But that's kind of a limited method because not every quadratic can be factored. In fact, most quadratics can't be factored. So what we're going to learn this time around is how to find roots or x-intercepts in any case, whether it's factorable or not. But before we jump into that, let's go remind ourselves how we did it before. So one, we can activate some prior knowledge and kind of get warmed up. But two, so we can better compare and contrast the old method to what we're going to learn today. So let me give you a function. Let's say x squared plus 2x minus 3. And let's say we wanted to graph this thing. Now the old method, the method I used 2 videos ago where we graphed by factoring, well, first of all, we factored. So can you factor this? Yes. What multiplies to give me negative 3 but adds to give me 2? Well, that's a positive 3 and a negative 1. So negative 1 times 3 is negative 3, and 3 minus 1 is 2. So that works. Then we said, well, how do I use this to find anything useful? Well, we recognized that if you set this equal to 0, then that means that you're demanding that the y value is 0. In other words, the height has to be 0. So whatever x value I'm going to get is going to be on this line somewhere. Right? That was the logic behind it. Well, what numbers could I plug in there to do that? Well, negative 3 will make this thing go to 0, and 1 will make this thing go to 0. So those are my 2 roots. So that's what we did. We went over here and we plugged in, or we plotted negative 3 and 1. And then from there, we recognized that if we knew the pattern, then we could fill in these other dots as well. Now, this only really works, to be fully transparent, this pattern of dots only works if there's nothing here, if there's a 1 out front. So if A is 1, then you get this picture of dots. But everything we did in that video followed that pattern. And that's what we did. All right, and you're already probably recognizing that this is pretty limited. It is very powerful. It's very simple to do if you're good at factoring, but it's very limited, right? Because this only works, 1, if you can factor, and 2, if the things that you get when you factor are going to be either 4 apart or 2 apart or 6 apart or something like that. It has to be very, very specific distances. So it is quite limited. So what we're going to do today is learn how to find these roots without having to factor at all. So whether maybe it's just that you don't want to factor because you're bad at factoring, it'll find them anyway. Or if it's just not factorable, this function or this formula we're going to use today will find them regardless every single time. So it's a very, very, very powerful tool. All right, now before we do that, let's continue kind of reviewing what we've done before. In the last video, we talked about how to find the vertex of a function. Now in this one, we already found it because you can just count. But what if we didn't? Let's just prove to ourselves that we can, in fact, do that. So we learned that the vertex formula, negative b over 2a, will give us this thing down here. In this case, well, this is a up here. This 2 is b, right? And c is negative 3. And so again, in our last video, we said, well, let's take b, and we do negative b, it's negative 2, divided by 2 times, in this case, a is 1. That's going to give us negative 2 divided by 2, which is negative 1. And that's half of our vertex, and we plugged it back in. And let me use a different color. So I plug it into our function, negative 1 squared, plus 2 times negative 1, minus 3. That's going to be 1 minus 2 minus 3, which is going to be negative 4. So my vertex is negative 1, negative 4, which in fact it is. All right. Now, again, if you drew the picture already, you would have known that because you could count. But if we didn't know it or we wanted to jump straight to the vertex, we could have used that. But this review just proves that this vertex formula is easy to use in whatever context. All right. Real quick, let's talk about what this C thing is, because last time we outlined what A, B, and C were, but to find the vertex, we didn't actually use C. What is this C business? Well, actually, C is very useful and very easy and quick to talk about. It turns out C is going to be your y-intercept every time. So whenever you have a quadratic that is in this form, we have x squared plus x plus another number, plus or minus another number. When it looks like this, then that last number is going to be the y-intercept, right? And that's just want to show you that really quickly. It's going to show up a lot more, and we're going to use it a lot more in future videos. But just to go ahead and get that out of the way, it's very easy to talk about. So that last number is going to be the y-intercept every time. Okay, so let's get on to this quadratic formula thing. Let's make this a little bit more formal here. Let's write down what the quadratic has to look like. Remember, we talked about how the number in front of x squared was a, the number in front of x was b, and the number by itself was c. Okay. Now, I don't think we ever named this. When a function looks like this, when a quadratic looks like this, it's called standard form. Let me move this down a little bit. I'm going to name this. It's very important to know these names. If for no other reason, then you'll see them pop up, and you need to know what they are. So this is the standard form. Let me write that for you. Of a quadratic. Now all that means, that's not the word quadratic. Quadratic. All that means is it's got a number times x squared plus a number times x plus a number. Now, this number here might be 0, so it might just be the first two terms, or the first and last. But the point is, there's no parentheses anywhere to be seen, right? It's just all multiplied out and simplified. This is the standard form. All right, and we already talked about just a minute ago that C is my y-intercept, right? So that's something you can pick out of this quite easily. And we use the the vertex formula with this format to find our vertex, but we're going to now introduce another formula called the quadratic formula. Let me see what color. Here we go. So here it is formally, the quadratic formula. And here it is. It's going to look real nasty and confusing, but I promise it's not that bad. Negative b plus or minus the square root of b squared minus 4 times a times c, all divided by 2 times a. I'm going to give you a second to write that down if you're taking notes. This formula is going to give you, I'll put x out here, roots. It's going to give you x-intercepts. We also call them zeros. Let me actually sketch this real quick for you. So if you were to, have a function or a quadratic looks like this, these values right here are roots or x-intercepts. They're also called, like I said, zeros. All of these terms are for the same things, so these two numbers. And this formula, this quadratic formula, will tell you what those numbers are in any case. That is, whether you can factor this or not, it doesn't matter. It will always work. Okay? All right. Let's jump into one of these and just give it a shot. Here we go. Let's try this. Y equals 2x squared plus, actually, you know what? Let's keep this really simple. Let's use the one we used before. 2x squared was at 2x minus 3. The reason I want to do that, even though we can factor this, which is what you should do if you can factor it, if we do it this way, you'll see that when you use the quadratic formula, it will in fact give us the same roots that we got before. So let's use this one. All right. A, I'll go ahead and label this, is 1. B is 2. And C is negative 3. All right, let's go over here and write our formula. negative b. Hopefully you've gotten written down. Gotten it written down somewhere already. But just in case, I'm going to rewrite it for you. Okay, so the formula says to put negative b. So I go negative, and then b is 2, plus or minus, square root of. And I have b squared, so I take 2 squared minus 4. This will always be a 4. I get questions about that a lot. There's not very many numbers in here. There's only a 4 and a 2. The 4 and the 2 in this formula will always be there. It's just part of it. Times a is 1, and then times c, which is negative 3. And then all divided by 2 times a, which in this case is just 1. All right, that's the first hurdle we have to get over, right? Just plugging everything in the way it goes. All right, now the next thing we have to do is look at what's under this square root, okay, under this radical, if you will. So let's do that first. I'm going to write down what's outside already, just to write it down. It's still there. I'm going to work on the inside now. 2 squared is 4. And then I highly encourage you not to write the negative yet. Just write down whatever that square is and then wait. And I want you to look at this. Let me actually change colors so you can see this. Pro tip here. Look at all of these together. So this is a number. This is a negative 4 times a 1 times a negative 3. Do that multiplication first. Negative 4 times 1 times negative 3 is a positive 12. So then I'm going to put plus 12. Okay, that's going to help you out a lot when doing these, if you're not good with negatives and things. All right, then divided by 2 times 1 is just 2. All right, let's keep going. Negative 2 plus or minus the square root of 4 plus 12 is 16 divided by 2. All right, this is pretty simple. I'm going to go over here so I have a little bit more room. Negative 2 plus or minus, so the square root of 16 is 4, and divided by 2. All right, now, there's a couple of ways to proceed from this point. I'm going to show you the most common way to do this, and then maybe later I'll show you a different way to kind of look at this. But for now, let's just make this very simple. I'm going to start on the top. This is actually 2 different problems. Let's actually separate this. So this becomes, let's try a different color. Negative 2 plus 4 divided by 2, and negative 2 minus 4 divided by 2. It's actually 2 different problems because we're looking for 2 different roots, right? So this was negative 2 plus 4, which is 2 over 2, which is 1. And this is going to be negative 2 minus 4, which is negative 6 divided by 2, which is negative 3. And look at that. Isn't that cool? So we got, using this formula, we got the exact same roots that we got before by factoring. So even if you can factor it, but you're not good at it, or for whatever reason, you can use this formula to do that. It's going to work every single time. Okay? All right, let's try another one. We're going to do several of these just to get really good at it. You're doing something that's kind of computationally intense like this, and it's good to have a lot of practice. Let's do x squared plus 5x plus 6. All right, I would suggest you try this one real quick on your own. Pause it, and then come back and see if you got the right answer. All right, here we go. So I have negative b plus or minus square root of b squared minus 4ac all over 2a. So b is 5, so I have negative 5 plus or minus the square root of b squared, it's 5 squared, minus 4 always, times a, which is 1, times c, which is 6, all over 2 times 1, which is just 2. All right, now I have negative 5 plus or minus. I'm going through this quickly again because I'm assuming that you've already tried these calculations. 5 times 5 is 25. Now this is negative 4 times 1 times 6. It's just negative 4 times 6, which is negative 24, all over 2. That's going to give me negative 5 plus or minus the square root of 1 over 2. Okay, That's going to give me, well, the square root of 1 is just 1, right? So I'm just going to go ahead and get rid of that. This is negative 5 plus 1 over 2, and negative 5 minus 1 over 2. That's going to be negative 4 over 2. Oh, let me write that a little better. And this is going to be negative 6 over 2. You can work out each one of these to completion first. Like, in other words, you can do this one first and then the one below. I'm kind of working them simultaneously. It doesn't really matter how you do it. Negative 4 divided by 2 is negative 2. And this is going to be negative 3. All right. And you can even check to make sure these are correct, right? So these are the roots. And if you wanted to kind of reverse engineer this, if you will, that means that the factors, if these are whole numbers, that means that you could have factored it to begin with, would be x plus 2 and x plus 3, right? Those are the factors that go with these numbers. We would just switch the signs back in. And if you multiply all this out, you will in fact find that you will get this quadratic back. Right, so that's a way you can check to make sure you did it properly. You just stick it back into this factored form and then multiply it out, and you'll get x squared plus 5x plus 6. Okay, let's do another one. Try this one. It's going to be similar to one we did a minute ago, but I want you to see something really interesting with this one. Y equals negative x squared. Let's do minus 2x plus 3. That should work. Okay, try this one on your own, and then we'll do it together. Okay, here we go. I'm going to write down negative b. So negative b, well, b is negative 2 in this case, so it's negative 2. You could write that if you'd like to. I usually just kind of skip that step because I know that negative b is just going to switch the sign, right? If it starts as a negative 2, it's just going to end up being a positive 2. So you can write it down here like this, or you could just go ahead and switch it, right? So I'm just going to write 2 because I have switched the sign. I didn't switch it just to switch it. I switched it because it's negative b, right? Okay, square root of b squared, that's negative 2 squared, minus 4 times a. A in this case is different from what it has been. It's negative 1. And then times 3. All over 2. Oh, my board's not working. Hang on. 2 times negative 1. All right, let's keep going. So I have 2 plus or minus the square root of. This is 4. And this is negative 4 times negative 1 times 3. That's a positive 12. All over negative 2. And now this is going to give me 2 plus or minus the square root of 16 all over negative 2, which is 2 plus or minus 4 all over negative 2. Now, I'm going to pause right here. You can finish this if you wanted to. And in the way we did it before, actually, let's do it real quick. So this is 2 plus 4 over negative 2, and 2 minus 4 over negative 2. 2 plus 4 is 6 divided by that is negative 3. 2 minus 4 is negative 2 divided by negative 2 is positive 1. So those are your roots. Okay, and then, of course, from there, you could graph it, or you can do whatever you needed to with this now that you have the information. Right? But I want to show you something kind of interesting. Check this out. Now, this is kind of a bonus section, so if this bothers you, don't freak out. But I find this really fascinating. Check this out, because I wish somebody had shown this to me a long time ago when I was learning it. I want you to notice that you can separate these functions out. See this division, it's 2 plus 4 divided by negative 2. Really what's happening is you can think of this as 2 divided by negative 2 and 4 divided by negative 2. You can separate this out. Let's try that. So I'm going to separate this into 2 divided by negative 2 plus or minus 4 divided by negative 2. Okay, so all I did, it's nothing crazy. It's just basic algebra. I just broke this fraction apart into two fractions. Both of these numbers in the numerator are both divided by -2, so you can do that. Let's simplify this. This becomes -1 plus or minus -2. Oh, sorry. You could do -2, but also, since it's plus or minus, it doesn't matter. So plus or minus 2. Okay. Let's think about what that means. Think about this for just a second. That means that my roots, this is fascinating to me, my roots are going to be -1 plus 2 and -1 minus 2. Let's actually graph this a little bit. Let's put some things here on the x-axis. So -1 plus 2, well, actually, let's go ahead and talk about that -1 real quick. Let's go ahead and, now, -1 is not one of the roots. I want you to notice that. -1 is not a root. But it's important to this conversation because it shows up in both answers as you're calculating it. So if I add 2 to that, I get that number, right? That's 1. And if I go -1 minus 2, I get this number. So these are my roots, as we calculated before. -3 and 1 are my roots, right? But what I want to draw attention to is this -1 right here. It's not a root, but it is important because notice where it lies. Look at its location. The location of that -1, that number here, is in the middle of my parabola. It's in the center. And if you think about how a parabola works, a parabola is symmetrical, right? So in this case, it's upside down. So I'm going to try and draw this a little more accurately. If you were to draw the parabola, it's symmetrical, like this, right? Where does that -1 line up? Well, if you think about it, since it's in the middle, that -1 is going to be part of the vertex, isn't it? That's going to be the first coordinate of your vertex. Now here's where the magic happens. Watch this. This is really cool. Where did this come from? Well, if you think about where that first number came from, over here, right? If I wrote that formula out again, I know I'm kind of all over the place, but stick with me here because this is pretty amazing. The full formula, -b plus or minus square root of b squared minus 4ac all over 2a. These terms, so 2 over -1 or -2, where this number came from here is actually just what? It's here, isn't it? Does that look familiar? It should, because that is just -b over what? 2a. That is the vertex formula. This is actually where it comes from. So the vertex formula is simply part of the quadratic formula. It's the part of it before you start separating these roots away from it. Right? Now, you don't have to know that to calculate the roots, but I wanted you to kind of see how beautiful this is, that the number that's in the center of this parabola that forms the x-coordinate of the vertex is actually inside this solution. And you can work it out. If you wanted to simplify it this way, it's actually visible. -1 plus a number and -1 minus a number, right? And then, of course, to get the height, what would you do with that -1? You could plug it back in, and it'll give you that maximum, right? And also, while we're noticing all kinds of things here, also notice that, what else can you find? See this 3? We talked about how that was the y-intercept, right? Well, there is my y-intercept. Isn't that cool? And in fact, if you were to work all this out and plug that -1 in, you'd find that this dot up here is actually a 4. I'm not going to actually plug it in, but you'll see that that's what that in fact is the case. So I just kind of wanted you to see that the vertex formula that we learned about last time actually appears in the quadratic formula, and you can kind of glean some other deeper patterns and information if you kind of look at it that way. Pretty cool stuff. All right. Let's do another one. Let's try this one. Y equals x squared plus, let's do 3x plus 8. All right, go ahead and give this one a shot real fast, and then come back and we'll talk about it. All right, so negative b plus or minus the square root of b squared minus 4ac all over 2a. B is going to be 3, so it's going to be negative 3 plus or minus the square root of 3 squared minus 4 times a times c, which is 8, all divided by 2 times a, which is just 1, so I'll just write 2. Now, I have negative 3 plus or minus the square root of 9 minus 32 all over 2, and that's going to give me negative 3 plus or minus the square root of, oh my gosh, negative 23 all over 2. Now, if you've already done this, and you tried it before I did, you probably got to this point and went, wait a minute, this isn't a thing that I can do. So what's happening here? Well, if you know anything about square roots and radicals and things, you'll notice that this is something that you cannot do. You cannot take the square root of a negative number. It's not possible, at least the way we understand things right now. There are exceptions to the rule, and we will talk about them later, but we are not going into any of those things right now. As far as we know, it is not possible to take the square root of a negative number. So what does that mean? Well, what it means is there aren't any roots. Think about it this way. The function, the formula that gives me roots, so this quadratic formula is designed to find roots. This finds roots. What does it mean for this function to fail? In other words, what does it mean for me to not have any roots? Well, think about it. It means that the function never crosses the x-axis. So, if it crossed here, I have roots here and here, right? Or if it was upside down, something like this, you have roots. But it's perfectly plausible that you have a function that does something like this. Now notice, this thing does not touch the x-axis. Therefore, it has no roots. We're going to write no real roots for reasons we're going to talk about later. But this has no roots because it doesn't cross the x-axis. That's what this means. So if you have a negative underneath the radical here, you don't have any roots because it's above the x-axis like this, right? Now, we could, talking about that trick we learned a minute ago, actually, this piece here, negative 3 over 2, is going to give us where our vertex is. So negative 3 over 2 is negative 1.5. So right here, we know that's where that is. That's how I was able to graph that. So we know that information. And we know that this is the y-intercept, so this is 8. So we know some other information. And you could, again, plug in the negative 1.5 rather, into the function and get your height. So there's all kinds of information you can glean from this, but the quadratic formula is not going to give you the roots. Now, that doesn't mean that this was a futile exercise. It's not like we didn't learn anything. What did we learn? We learned that it has no real roots. That's not something it's not a waste. We didn't find the roots, but we found that they don't exist because this thing does not, in fact, cross the x-axis, right? Okay. Let's do one more, at least. Let's try this one. Give this one a shot. And then come back and we'll discuss this. All right, I'm going to assume that you've tried it. Now this one, if you've already tried it, you're going to already know that there's something else going on with this is a little fishy, right? Not quite as strange as the last one, but interesting nonetheless. That is, if I constructed this properly. All right, negative 4 plus or minus the square root of 4 squared minus 4 times a times c all over 2 times a. Okay, negative 4 plus or minus, there's 4's everywhere in this, 16 minus 4 times 2 times 2 is 16 all over 4. Well, look what happens. This is where this one gets a little interesting. 16 minus 16 is 0, right? So this is the square root of 0. What is the square root of 0? Well, the square root of 0, this shouldn't scare you. This doesn't mean anything crazy or wild. This is not impossible. It's perfectly valid. But it is something interesting to talk about because this is -4 plus or minus 0. In other words, this whole term here just goes away. There's no plus or minus anything. It's just -4 divided by 4. That whole term just disappears, right? So that's going to give me -1. What does that mean? Well, that means that the only root I have is -1. The only root is -1. What does that mean? Well, let's think about this. Think about what it means for a parabola to only touch the x-axis at one spot. Well, the only way that's possible is if it's on the axis somewhere, if the vertex itself is on the axis. And so you can think about it this way. At -1, let me graph this for you. Let me make this a little bit bigger scale here. So this is what's happening. Because you only have one root, and it's at -1, that is your vertex. And you will find that if you plug in -1 into this function, you'll get a height of 0. So the vertex will be, I'll leave that exercise to you. So if you'd like to prove it to yourself, you're more than welcome to do that. So when you plug it in, you'll get 0. So the vertex is -1, 0. And also, we know that the y-intercept is 2. This is our y-intercept. And also, you know that since parabolas are symmetrical, that if that is 2 over there, then there's a 2 over here, right? And then we can graph the function. Let's graph it really quickly. So I have something like this. It's not drawn to scale. It's kind of poorly done here. I apologize. That is pretty rough. Let me redraw that one. That dot's a little too far over, but okay. So there's that. It's symmetrical, right? And then we would graph our parabola like this. And we could anticipate this, right? Because this 2 out here tells us that we have, an over 1 up 2 situation. If you think back to how our parent functions, videos we're talking about. So this kind of brings all kinds of things to light and kind of brings a lot of things that we talked about before with our parent functions, where, if you have one root, it's on the x-axis, and you've got this, this business here where you go over 1 and up 2. It's kind of neat. So this kind of brings everything together. Okay, so I think this would be a good time to stop this video. This is what I want you to remember. If you want to find the roots of a function that looks like the ones we've been talking about in this video, first of all, try to factor it. That's the first thing you should do. Factor it if possible, especially if you're good at factoring, because usually that works out easier and it's quicker. But if you don't like factoring or you can't factor, use this quadratic formula to find your roots. If the square root thing ends up being 0, you just have one root like we have here. It's not a problem. You just graph it this way. And then if you end up with a negative under the square root, that's going to give you no real roots. That means that your parabola doesn't actually cross the x-axis. Again, not useless information. It's just, it's something to note if that does in fact happen. Okay, great. That will conclude this video. Thanks for sticking with me to the end. The next video, we're going to talk about a different form of quadratic function, things that don't look like this. And it's going to kind of be a little bit of a review. We're going to kind of go back to the way we thought about functions when we were doing parent functions and kind of expand on that a little bit. Okay. So again, thanks for sticking with me to the end. Hope this was useful, and I'll see you guys in the next video.